Good day, students. Today we're looking at a solution to a problem that's found on page 40, chapter 6, book 3. Deals with the cone, finding the surface area and volume questions. Alright, so I have the question already there, as you can see. And we're told the funnel is in the shape of the cone. The first question says how many square centimeters, okay, square centimeters, right, see it there, meaning if you see square centimeters or how much material is required to make something, that's surface area, okay. So we're looking at surface area, okay, of the filter paper. Do you need to line the funnel? Now I've brought in an extra picture here of a coffee, making coffee through a paper filter. And as you can see, the funnel is the glass part right here, and the filter is put in the funnel, and we wanted to know how much paper. But notice there's no top. There's no this is not a closed cone. There's no top on that filter. So if you look at the surface area of a cone, we know that it involves two parts. It's called pi RL. Pi times r times L, the lateral value or lateral side, plus pi r squared. Okay, so if you look at the question, that's for the full cone if there's a circle on top, like a closed cone. Well, see, we have no circle on top in this case, right? There is no circle on top of this cone over here. Alright, so we don't need that part, okay, of the formula. We're only looking for the lateral surface if we're just doing the paper filter. So the surface area we require today is just the lateral surface area, okay. So in this particular problem, it's not the complete surface area. So I'm just going to write surface area, and I'll put the word lateral portion only. Now that's just pi RL. We don't need the circle part, plus pi r squared. So that's all we need to find. Okay? So now the question comes, do we know the radius, and do we know, okay, the lateral, the length of the slanted side or oblique side or lateral side, whatever you want to call it. Now look above again in the cone there. The lateral side, of course, is this side right here. Alright, see that one right there. Okay, and we don't know that value, do we? So you have an extra step here before you can even move on to finding the surface area of the lateral portion. You've got to find the length of the lateral or oblique some call it slanted height, some people call it the slant height, some people call it the oblique height, some people call it the lateral height, right? Whatever one you want to call it. See it there, it's changing colors now. So any one of those, okay? So what do we do to do that first? Well, if you look down on the bottom here, I'm going to draw a right triangle now using the lateral height. So let's see what we have here. Alright, let me go. So we have, here's our perpendicular height, right? That's referred to as perpendicular height, right? Then we have our lateral height. Let me draw that. Okay, here we go. Oops, not working. Hold on, what's going on here? I'll delete that and I'll draw it by hand. Doesn't seem to be working correctly. So I'm just going to draw the portion from the cone that looks like a right triangle, right? So this is my lateral height or slant height, okay, and this is my radius is 4 centimeters, and this is the perpendicular height, 7.5. So you can see that before I can even use this formula here, I need to find L. I don't have it. See, there's several steps to this question. So let's go ahead now and find the lateral height first using the Pythagorean theorem. Okay? And let's see what we got here. Now, it is the hypotenuse, right? So therefore, the lateral height in this case is going to equal the perpendicular height, right, plus the radius. So it's 4 squared plus 7.5 squared. So let's go ahead and work that out. 4 squared is 16. 7.5 squared, I get 72.25. You can check that on your calculator. That's L squared. And L equals the square root of that, 72.25. So L is equal to 8.5. And let's double check. This is in centimeters. So this is our first step down here. See that? Now we have the height, or the lateral height. So this distance here is 8.5 centimeters. Now I can figure out how much paper lines the inside of that cone. How much paper, right? Square centimeters. So it's pi times the radius, which is 4, times the lateral height, which we just found to be 8.5. Okay, we'll go one decimal place. So let me just see what I get here. Second function, pi times 4 times 8.5. I get 106.8. 106.8. And again, this is centimeters squared. It's only the inside part, the lateral surface area of the lateral portion of the cone, okay? Because we have no top on this particular example. No circular top. Now, the next question, how many milliliters of water can the funnel hold? Now hold, how much it can hold, it is volume. Milliliters is volume, right? Very similar, or capacity, and cubic centimeters is volume, but in this case the same thing. So the volume, and that's also a formula given. So if you look on your different formula sheets, the volume of a cone, okay, is 1/3 pi r squared times h. Okay, and we have all that information, don't we? We know what r is. R is 4 centimeters. Going to square that times the height. The perpendicular height is h, remember, and that's 7.5. So the volume of this cone is going to be, okay, I'm going to check that on my calculator again. Second function, pi times 4 squared times 7.5, and I get and divide that of course by 3. It's 1/3 of that, so 125.66. so I'll say 125.7. okay, 125.7, and that's cubic centimeters. Now if you want it in milliliters, it's the same thing. 1 cubic centimeter is the same as 1 milliliter. So this is the same as 125.7 milliliters as well. Okay? So cubic centimeters and milliliters are the same thing. Alright? So it can hold 125.7 milliliters. So there's the answer to number 18. Okay? In the sample assignment in chapter 6.